bunch of things to talk about today. Alright, so first of all, deadline for second version of SLP proposals was this morning, and I'm still missing a few. So you have one more deadline, which I believe is Wednesday. Check Canvas to get your SLP proposal submitted. Submit under proposal version 1. Version 2, 3 are just placeholders for the grade. If you got a 0 on your SLP proposal, take a look at the comments and I'll tell you why you need to resubmit. In most cases it's because there were no milestones, which is an essential part of the proposal. But take a look at your comments and please get those turned in. On the subject of SLPs, we have this option for extra credit Friday afternoons during the club meeting if you want to give a 5 to 10 minute presentation to the club. Most slots are open. This coming Friday, I think we've got 4 or 5 people signed up already, so I think there's 1 slot still available this Friday. And I think there's also some visitors from some area businesses coming to the meeting to listen to people's proposals, so it's a chance to get some visibility and feedback from people who know what they're talking about from an industry perspective. So, but all the way through week 8, I believe, is the last one. You can come to the club and pitch your idea, get some feedback, and get some extra credit here. So I strongly recommend taking advantage of that, right? Because week 11, you're going to be talking to people about this during the club expo. And this gives you some practice with that and will help you figure out what you're trying to do and formulate your ideas a little better. So definitely take advantage of that. Homework 2, about a quarter of the class did not turn in, and I'm not sure what the problem is, but let me know and we'll figure it out. Yeah.
So, yeah, I just checked and it looked like I apparently didn't turn it in.
Okay.
And then, so I went to GitLab because I know I did it, and for some reason I remember putting you on as a reporter, but it was like it took you off.
Oh, okay.
I don't have you as a reporter, so I miss points, all points.
Okay.
Me too.
So
Back on, but
okay, yeah, so when you add as a reporter, you've also got to scroll down sometimes and find the thing that says save changes or something like that.
oh, I don't see it save changes anywhere.
It
There's-
normally auto does on GitLab.
For me, it always makes me do it.
Really?
Yeah.
Only weird edges.
Yeah, I don't know.
Yeah, once you click add to project, that's the save.
Right, yeah, so add to project is the magic. Yeah, that one. Yeah, so if you didn't get it set up in time, get it set up and send me an email, okay, and ask me to try it, and I'll try it and let you know if it worked or not. If you did get it submitted on time, I've downloaded it, but I haven't looked. But I'm assuming that you made a script called lowercase hl and you put the bin bash and put a comment after it. But I'll go through and double check that and then record the grades for that. Um, all right, so that's homework 2. Let's talk about the ODP 413. Right, so the goal was this function count E takes a character pointer, a string, tells you how many lowercase e's are in there, and returns that number. And as usually happens with these, right, it's not that it's a lot of code, it's getting it nailed down just right, right? So I included string because I'm using string length, so count E, character pointer. And then I'm using C to count the number of characters that are the letter E. I'm using I to move through the string. I got 2 things here, 2 integers, right? So I is just an index through my array. C is the count of the number of letter E's. So for loop, I equals 0 less than string length of my argument, I plus plus. Arg bracket I is the ith character, and I'm saying equal equal single quote E. And if that's true, then I increment C, and then I return C at the end. So there's a few things to talk about here. And let's just play with some code. So this is test code. So I'm going to print out. Let me not make it fancy. Let's look at what E in single quotes is, and let's look at what E in double quotes is. And I'm going to print them out as both just %D. I'm going to ignore compiler errors. So E in single quotes is 101, E in double quotes is 4 million something else. And if I run it again, E in single quotes is still 101. E in double quotes is the same value. Okay, but it's a weird value. If I try an A in single quotes is 97, A in double quotes is the same weird value. Right? Pull out an ASCII table sometime and look up what the ASCII code for little a is. It's a 97. Little e is 101. Right? So single quote E is the same thing as the ASCII code for that character, E. And it's just an integer. It's a short integer. It's an 8-bit version. A in double quotes, E in double quotes is something very different. It's a big long number that we have no business dealing with. It's an address. It's a location in memory. Because when we say something like double quote E or double quote hello, what the compiler does is it finds some location in memory and it stores that letter E followed by a null terminator. Or it stores the letter H, E, L, L, O, and a null terminator. And then the value of this string is the address of that first letter. The value of this string is the address of that first letter. So double quotes are making an array, right? Because that's how we do strings in C. We have an array of characters stored one after another in memory. Single quote is just a character. So if you're looking for something to compare with a character like the letter E, right? A single quote will get you there. So that's what we're doing if this argument's equal to single quote E. What else is going on in here, right? It's a character array. It's a string, but it's really just an array. So R bracket I gives us the ith element. And this is just something you have to go back to a few times. So if our string is hello, that's HELLO followed by a null terminator, it's an array. So this is HELLO, null terminator, and then who the heck knows after that. Yeah?
Does double quotes 0 point to the null terminator?
No. Double quote 0 would be an address somewhere in memory where it decided to store a 0.
Okay.
And it would probably not be 0 itself. But NULL is a null terminator, and that's just a 0.
So number 6 is other things not related to this.
Number 6?
Yeah.
Yeah, it's whatever happens to be there. So if I call string length on this string hello, it's going to give me back 5. Okay, string length is a number of characters up to, but not including the null terminator, so it's just HELLO. Which means the last actual character of my string is at string length minus 1. So usually if you use a for loop to go through a string, you're going to start from 0 and you're going to continue as long as your index is less than the string length. Once it's equal to the string length, you're looking at the null terminator. So we usually have a less than in there. And if you did this as a while loop, you could say, while argument bracket I is not equal to quote backslash 0. All right. The other thing going on in here is when you're writing a main program, you have a statement like this prototyping of the function. And then when you're calling it, you're doing something like this. So there's 3 things we do. This is a function prototype. That's just something we put, say, in a main program to say, hey, when I say count E, this is what I'm talking about. It's a function that takes a character array and returns an integer. This is a function call. Here we've got presumably a character array named temp and an integer named I, and we're saying I want to run this function. I want to pass it an argument called temp. Execute the function. When it returns whatever value it said return, that's what I want to set I equal to. Okay, so that's a function call. And then somewhere, maybe in a separate file, we have the actual function code. This is where we actually write the function. So it does some stuff. And then it returns something. and they're all slightly different from each other, right? Writing the function itself, right, you have to say what it's going to return, you have to say what type of argument it is, you also have to give that argument a name so that you can refer to it inside your function, right? For example, if you're writing the count function, we can't look at the elements of arg unless we've told it, the argument coming in is called arg, and then we look at that. So that's writing the function. Okay, calling the function, we specify the name of a variable that we want to pass. We don't say car temp in here because the system already knows temp is a car because it must have been declared somewhere. So you just list your arguments that you want to pass, just the names of the variables. And if there's a return value, you can assign it to something or print it or do whatever you want to do. The prototype is kind of in between those two. It's setting up what this first line of your function code is going to look like, but it doesn't actually have the body of the function. Okay, so it's just sort of the header of it. And we don't need to put a name for the variable here because we're not writing any code up here to say what we should do with that argument. It only needs to know the argument is a character. So 3 different uses, and you probably want to keep those straight. Otherwise, you end up trying to put argument types in here or forgetting variable names there or things like that. Yeah.
So in C, you say the data type and assign the word for it, what does bash do?
Bash kind of figures it out. It's sometimes called duck typing. If it looks like an integer and it sounds like an integer, it's an integer. So it just sort of figures out, but really in bash everything is a string. But kind of on the fly, like if you say if this string is -eq0, it'll on the fly try to turn it into an integer and see if that's equal to 0. But really all the variables we use in bash are just strings of characters. But it's pretty weakly typed, definitely compared to C. So there's a count function. So I use the word testbed, and I haven't really talked about testbeds. I kind of assumed people knew what that was, but that's not a good assumption. I talk about testing your function before you try to assess it, right? Because assess doesn't tell you anything. It says 100%, 0%. It doesn't really help you debug your code. So you've written your function. You want to know if it works, right? Well, you can assess it, and if you get 100%, it probably was written correctly. But you'd like to do some testing beforehand, right? So a testbed is just a main program that calls your function. It's nothing formally defined. Here's an example of a testbed for this function. I prototype the function in the top, right? Because I'm not writing the function in here, but I'm telling it what this function takes and returns. And then I call my function. I pass an argument that I specify just inside double quotes. So this is the string hello. And this function call should return an integer. And I'm using that as an argument to printf. Now I can say printf county returns %d quote comma. I should have an integer after that comma. Well, the integer I have is just the return value from this function. And same thing down here in the second line, the third, and the fourth. So I should get back however many e's are in each of these strings. And so if I want to test this, I can say gcc, make my output file main, that's my executable program name. I want to compile main.c, that's the test file I just showed you, and my count function.c, and then run main, and it shows me the values that count returns. And if I look at it, right, hello should be 1, 3 should be 3, GGG should be 3, and ABC should be 0. And I would do some extra tests in here. I would try with a totally empty string. I would try it with a single E with other stuff after it. I would try it with stuff with a single E at the end. And, you know, be imaginative. Try to come up with a lot of different test cases. Why? Because you're doing a loop, you're looping through. What if you say for I equals 1, I less than or equal to string length? You're going to be missing the first character in your array. That's a really common mistake, right? So test something that has an E in that first character. I mean, you should get that too. And same thing with the last character if you stop your loop too soon. Maybe you check to see if it's a null terminator and then you increment or something. So just come up with test cases, right? Try to think of ways that you can break your code and test all of those. And then if it passes all of your tests and you assess it and you're getting 0, right? And you want help, so you can do something like, you know, cat main dots. Well, let's clear this. Cat main dot c, cat count e dot c. Right, run your assessment, do your grading, exit, and then go back here, grab all of this, paste it into an email, right, and just send it to N. Macias at Clark. And I'll look at it and I'll say, oh, well, you tried to use the assessment when ODP 414 was running instead of 413, right? But usually it's something more subtle than that. All right, does that make sense? All right, so let's look at 414. All right, so we're just playing with string processing through these ODPs. So this is a mix function. It takes in 2 strings. Takes in 3 strings, but the third string is going to get overwritten, right? So it takes a and a B and an out, and it should interleave them. And for simplicity, you can assume A and B have the same length. So I don't have examples here. Let's find some examples. Well, let's just write some. Okay, so integer mix. 3 character pointers. Does it return anything? Yeah, but I don't say what the return value should be, so you can return whatever you want. You can return any integer that you want. All right. So if you call this with strings like hello and A, B, C, D, E, it should change the contents of this third array. Right, let's just call this temp. After you call mix, it should modify the contents of temp so that temp looks like this. H, A, E, B, L, C, L, D, O, E. and a null terminator. So let's make a test bed for this. Alright, so I happen to already have a mix.c, which I'm not going to show you the code for. So I'm going to make a test file called testit. So that's the function we're testing. It's the mix function. Alright, so it's taking two strings, mixing them together into a third string. So I need a third string that I can mix into, so I'm just going to make a string called temp. And I'm going to say mix hello A, B, C, D, E. I'll do these lowercase. And temp. And I don't care about the return value, so I'm not assigning it equal to anything. I'm going to print out the value of temp after I call mix. I'm going to put it in angle brackets because I want to know if there's extra spaces or anything weird after there. Right? And there's my whole test bed. So that's a way you can call your mix function as you're developing it. So let's try running this. So run it, and there's my mixed up string, hello with ABC mixed in between. That looks good. So let's change this. Well, let's just do a few of these. So let's mix two empty strings. Let's make sure that works fine. Let's make sure mixing a string with itself works fine. Let's try some spaces. Yeah, I don't know, what else can we try? Let's mix 1, 2, 3 with some spaces. Let's mix some spaces with 4, 5, 6. You probably get bored about that point, so that's a good set of tests. I don't know what else we might want to try. If things weren't the same length, we could come up with a lot more test cases. First string could be empty, second one could be empty. They could both be empty. First one could be longer, second one could be longer, right? But for now, everything's supposed to be the same length, so there's some driver code that should give us some interesting results, maybe. So let's compile that up and run it. And then you stare at it and you convince yourself it's either right or it's wrong. Second one looks good because that should be empty. Third, just doubled every letter, good. Fourth one looks interesting. The fourth one, I didn't make my strings the same length. Because A space B space C is only 5 characters. So fourth one looks good, fifth one is 1, 2, 3 with spaces after, sixth one is 4, 5, 6 with spaces before. Does that make sense? So I mean, that looks like a good function. But you know, that's not precious test code, that's just stuff off the top of my head. There's value in sort of coming up with your own test code and writing it, and changing it around and playing with it. But that's just an example of how that works. So then link it in with the test bed. Don't try to assess this program, right? Because if I assess this, right, it's going to get zeros all over the place, plus random errors and things like that. So don't assess your test bed program, right? Link it in with /temp ODP 414 main.o, and then try assessing that. And that should do 10 out of 10 across the board. Questions? So how do we do mix? How do we mix these strings together? What's an algorithm for making this output string that combines the two inputs?
You could use string length to get the length of one of them.
Okay. So use string length to get the length of either first or second. They should be the same. So let's say we find out that these are 5 characters each. So maybe first is hello and second is A, B, C, D, E. And so we need to create this output array. So if we get C, how would you do this just on paper?
I initialize 3 different counters,
Okay,
I, J, and N.
so I'm going to have a pointer to this, I'm going to have a pointer to this, and I'm going to have a pointer to this.
Yep.
Okay, so I got 3 counters that basically keep track of where I am in each of these arrays. And then what? So a good way to do programs like this is just think about if you were asked to do this task. If someone said, I'm going to give you 2 strings of equal length, I want you to interleave them and give me an output string on the board or a piece of paper or something. It's easy to do, right? I'd say H, A, E, B, L, C, and so on, but how are you doing that, right? Try to analyze what the actual steps are that you're taking. And that's a tricky thing to do. It's like, how do you walk? It's a really hard algorithm to describe because there's a lot going on. But think about, what am I doing? Well, I'm taking the first character from the first string and I'm writing that down. And then I take the first character from the second string and I write that down. And then I move to the next character on the first and write that. And then I move to the next character on the second and I write that. And now we got an algorithm going. And why am I done? Because I ended up pointing at the 5th character and I knew my length was equal to 5. So if I try to move my arrow one more time, that index is 0, 1, 2, 3, 4, now it's equal to 5. So there were steps in there, right? So add first. So maybe I is my arrow for this first word, and maybe J is my arrow for the second word. So I said I equal to 0 and J equal to 0. And maybe K is my arrow for this third word, so I set K equal to 0. And I want to take this character from the first one and add that to my output. So I want to do something like out K equals first I. And then I need to move over to my next one, so I'm going to increment K. And out K equals second J. So that adds an A to it. And I need to move K again. And I need to go back up to the top, but before I do that, I need to increment I and increment J. And I want to go back to the top if those things are less than the string length of either first or second. So we've got a bit of a flow chart started here, right? And you can formalize that into more of a flow chart, and then you can start trying to turn that into actual C code. But that's kind of how you develop these things, right? And a tricky part on this one is after we've added the O and we've added the little e, we might think we're finished, but we're not, because we need to make sure we put a null terminator at the end of this. And knowing exactly where to place that can be a little tricky. But if you work through this logic, you're probably going to find that it ends up just at location K, whatever K happens to be. If K is always the spot where the next character is supposed to get written. But, you know, write it out, work with some smaller test cases, and figure out the details. And then write that in a C function and then start testing it. Does that seem doable? Okay.
What would happen if you didn't have the null terminator at the end?
It will almost certainly not assess. What will happen is that this output would be equal to this string plus whatever else happens to be in memory until you bump into a null terminator. And so you might get lucky and there might already have been a 0 sitting here, but chances are there's gibberish for a few spots and then a null terminator, so your string just has extra stuff at the end. Worst case, you segfault, because when you try to print this out, it just keeps going and going until it bumps into something it can't bump into. All right, let me mention something that I've mentioned to a few people. There's a website called W3 Resource. I don't know a whole lot about them, but I have students who occasionally ask me where they can get more practice with stuff, and this is one of the sites I found that I think is pretty good. W3resource.com. If you come down to exercises with online editor, there's a section for C programming. And it's got a little blurb about C and such, but there's collections of exercises over here, so basic declarations and expressions. There's 85 exercises here, starting with write a C program to print your name, date of birth, and mobile number. Write a C program to print a block letter F using the number sign, or a block letter C. And they go on, write a C program to compute the perimeter and area of a circle with a radius of 6 inches, and it should print out perimeter equals area equals. And for each of these, you can say go to editor, and you can write in some test code here. Right, and then you can say run, and it'll execute your code, and it'll show you the output down here. And if you got errors, it'll show you errors and tell you where they are, and so on and so forth. And you can also click on these and say show me the solution, and it'll show you code output, it'll show you the code itself, it'll show you a flow chart, and then it'll give you another spot where you can copy and paste that code and modify it and so on and so forth. So I think it's a decent resource for playing around with some of these things. The problems get increasingly complex. So write a C program that reads in a 5-digit integer and determines whether or not it's a palindrome, right? So kind of 121 flashbacks. And there's sections on different algorithms, so 75 of these. Find the absolute difference between two numbers. Create a new array taking the elements after the element value 5 from a given array of integers. I mean, just all kinds of stuff. These are like calisthenics, right? They're not really terribly useful by themselves, kind of like jumping jacks don't really help you build a house or clear a roadway. But they're exercises, right? They give you practice at doing things. And it's a decent environment. I mean, you just go in there and you type your code and you compile and it tells you where the errors are and so on, and there's solutions if you want to see helps. And they get increasingly complex and involved. But if you want to play around with some of these earlier ones, I think it's decent practice. If you're feeling like you're just kind of like rusty or not really confident with some of these things. If you go to the input-output section, these are things that are using fgets and scanf, right? Some of the earlier ones just use scanf for input because they're simpler exercises. But the ones labeled input-output, these tend to use fgets and scanf in different forms, so you can get practice on that. I don't know if they have ones for argc, argv, but if you know how to use fgets and scanf with strings, argc, argv is not that much different. So anyway, that's a resource to take advantage of if you like. All right, we're just about out of time. I did post a list of possible topics for the midterm, so take a look at that, and we can talk about it tomorrow. The midterm is really just Bash and C and Unix, but basically stuff we've been doing so far, so possible midterm topics. And there may be other things on here that I haven't thought of, but some Linux commands, Bash programming, C programming. So look those over and ask questions about it tomorrow. All right, so I'll see you tomorrow.